We're going to do a simple experiment with a hydraulic system. These are plastic syringes. I have a large one that holds up to 60 milliliters. I have a smaller one that holds up to 20 milliliters. And you can see that I've filled this with just over 20 milliliters of water. Now, when I push on the right side, what happens is it pushes the water into the left side. And I want you to notice that the water is conserved. So the 20 milliliters that I push to the right side, let's see if we can get a nice view of that. There's that 20 milliliters. Now I want you to notice something else. The large syringe piston does not move as far as the small syringe piston. The volume of the water is the same, but the length of the water is not the same. The length of the water is inversely proportional to the area. Consequently, the forces are different. Remember, work is conserved, so force times distance on the large piston equals force times distance on the small piston. So when this distance is smaller, the force is bigger. And on the other side, when I push on the small piston, because I've got a longer distance, I have a smaller force. So we're going to do a little lab to look at the relationship between the force of the large piston and the cross-sectional area, and the force on the small piston and the cross-sectional area. So to determine cross-sectional area, I'm going to need the internal diameter of the piston. So I've got a vernier caliper here, and the first measurement I would like you to take is the inner diameter. So pause this video and determine the inner diameter of that. Then I will do the small piston or small cylinder. The piston is actually the white part inside. So I've measured that inner diameter, and now I'd like you to look at this and determine the inner diameter. And now we're going to look at the ratio of forces, and I have a setup for that. So here is my iPad, and I'm going to start a new experiment with wireless devices. Let me zoom in a little bit so you can see what I'm doing here. Oop, and let me get my angle, get that glare out of the way. Okay, so I'm going to add some wireless devices and turning on my sensors. So I'm turning on these two blue sensors. I also want you to notice I've actually clamped the pistons, or the cylinders rather. The outer cylinder is clamped to the table, but the piston, the white part, is free to move. Okay, so let me add my devices. H1, this first one, is the one on the left, and N5, this other one, is the one on the right. So fortunately for me, these two windows with my forces here, those match my two force probes. So the window on the left goes with this force probe, and the window on the right goes with this force probe. So that's pretty slick. So now what I'm going to do is I'm going to push on the right force probe and see what happens to the left one. Before I do that, though, I have to zero my equipment. So let's just get set up here. So I'm going to tap it and hit 0, tap that and hit 0. Okay, I'm just going to zoom in on our iPad. And I'm going to collect this data. So now I'm going to push. Okay. Let's see how we did. Oop, I hit collect again. I didn't want that. Let me try that one more time. Actually, for the purpose of taking data, what you can do is just look at these two. That's probably what we should do. Just look at the two force numbers, and I'll zero these to start again. And I want you to pause 7 times and get 7 different readings. It's going to go kind of fast. So pause 7 times and get 7 readings. Here we go. Okay. Then I want you to make a graph that will allow you to look at the ratio of forces. I want the slope to represent the ratio of forces of these 2 force probes.